Okay, welcome to solving systems of linear equations using the row reduction method. We need to understand some vocabulary, so we're going to talk about what we mean by an augmented matrix. What are augmented matrices? We're going to use them to solve systems of equations. In order to create an augmented matrix, we need to make sure our equations are lined up properly. So I want you to look at this system of equations. System means we have more than one. In this case, we have two equations, two variables. We call this a 2x2 system. Two equations, two variables. So what I have is I have the x's lined up. Notice what we have right here. The x's are first. The y's are second. Then we have the equal signs. Notice the equal signs are lined up. Notice them. And then the constants. So we have to have everything lined up properly, everything in the same order. So we'll put these in standard form. And the standard form is ax plus by equals a constant, dx plus ey equals a constant. So the coefficients are what we're going to work with. We're going to be working with the coefficients. Let me erase all this. So from our equations, we now make an augmented matrix. What we do is we just take the coefficients of x and put them in the first column. So notice these are the coefficients of x. So these are the x coefficients in the first column. Notice the -2, right? Notice the 1. There it is. So those are the coefficients of x. And then in the second column, we have the coefficients of y. Notice that's 1y. There's the 1. Okay. There's a -4. So those are the coefficients of y. So we have our x coefficients, we have our y coefficients, and then we have our constant terms. Notice where they are. -3, and then the -2. So each row of that augmented matrix, each row, top row represents the first equation, -2x plus y equals -3. The bottom row represents the second equation, 1x, so x minus 4y equals -2. When we have an augmented matrix, every row represents a linear equation. Okay? So we're going to do one example here. We're going to write an augmented matrix for the system. So notice that everything is lined up. There's the x's, there's the y's, there's the equal signs, there's the constants. You need to make sure everything is in standard form. And then we're going to write our augmented matrix. So you can either do column by column, or you can do what I do and put them in one row at a time, because each row represents an equation. So there's 3x minus 2y equals 14. And there's 1x plus 3y equals 1. And we're done. It's just that simple. So that augmented matrix represents the system of equations. We don't write the variables and we don't write the equal signs. We only write the coefficients and the constants inside the matrix. Okay, now we're going to talk about how to solve a system of equations, solving systems of equations using these augmented matrices. So what we're going to do is we're going to use some matrix row operations. Sometimes they're called elementary row operations, to turn the left part of our augmented matrix. So right here we have our A, B, D, E, the coefficients of x in the first column, the coefficients of y in the second column. We're going to use some row operations to change it to where we have the identity. And then that top row will say 1x equals, and whatever this number is the x value of the solution. And then in the bottom row says 0x plus 1y equals, whatever that number is then the y value of the solution to the system. So we need to understand what the row operations are. What are we allowed to do? There are 3 things that we're allowed to do. We're allowed to switch rows. We're allowed to multiply a row by a number, but it has to be a non-zero number. Don't multiply by 0. That doesn't work out well. So multiply by a non-zero number, or we're allowed to add rows, or better yet, add a multiple of one row to another row. We can add a multiple of one row to another row. And then we're going to show you how this process works. So we're going to solve the examples from up above, the two examples that we have. Now remember, this first augmented matrix is the system negative 2x plus y equals negative 3, together with the second equation, x minus 4y equals negative 2. And what we're going to do is we're going to turn this into a 1 somehow and this into a 0. But we're going to do the 1 first. So I'm going to work one column at a time. So I'm going to work on column 1. Okay, I'm going to get the 1 in place, and then I'm going to use the 1 to get a 0 below it. So column by column, that's the key, one column at a time. So what I'm going to do first is I'm literally just going to switch row 1 with row 2. So I'm going to switch row 1 and row 2. Maybe I'll use this notation. I'll do R1 for row 1. I'll do R2 for row 2, and I'm just going to switch them. Okay, so I'm going to make that switch. I'll write this over here a little bit further so I have more room. So we're going to switch row 1 with row 2. So we now have 1, negative 4, negative 2, and negative 2, 1, negative 3. Okay, the first step of our process is done. The 1 is in place. Now I'm going to use that to get a 0. And if we had a bigger system of equations, we would do this same column by column process. So now what I'm going to do is I'm going to add a multiple of row 1 to row 2 to get a 0 where this negative 2 is at. See where that negative 2 is at? I need a 0 there. So what I'm going to do is I'm going to do 2 times row 1, because that would be 2 times 1. See this 1 right here? That would be 2 times 1, which is 2, and 2 plus negative 2 is 0. All right, so we're going to do 2 times row 1. And we're going to add that to row 2, and I'm going to put that in as my new row 2. Okay, so here we go. Top row is not changing. It's still 1, negative 4, negative 2. Bottom row, oh, you know what I like to do? I like to pencil in the numbers that I'm going to add so I don't have to flip-flop back and forth between multiplying and adding. So I'm going to multiply 2 times row 1. So 2 times 1, 2 times negative 4, and 2 times negative 2. Now I'm going to add those. You don't have to do it this way, but I find it helpful. 2 plus negative 2 is 0. Negative 8 plus 1 is negative 7. And then negative 4 plus negative 3 is also negative 7. Right? Now we are ready for column 2. So do column 1 first, and then do column 2. So I need a 1 where this negative 7 is at. I can divide by negative 7, which is the same as multiplying by negative 1/7. Remember what we said? One of our operations is we are able to multiply a row by a number. So since dividing by negative 7 is the same as multiplying by negative 1/7, we'll do that. So row 2 times negative 1/7. So what we now have, we're not changing the top row right now. I'm just changing the bottom one. So 1 and 1. Okay. Now I'm going to use the 1 to get rid of the negative 4 that's above it, because I need a 0 right here. Okay. So I'm going to do 4 times row 2 added to row 1 and put that in as my new row 1. Okay. So I'm just going to pencil in the numbers that I'm going to add. Let's see. 0 times 4, 1 times 4, 1 times 4. And then I'm going to add those numbers. So now I have 1, 0, 2, and 0, 1, 1. I hope you're writing pretty small so you don't run out of room. Should have warned you about that. Okay, now we have our solution. this top row, let's start at the top. The top row says that x equals 2 because it's 1x plus 0y equals 2. And the bottom row says 0x plus 1y, or in other words, y equals 1. So my solution is the ordered pair 2, 1. That's my answer. Now, I am a big fan of checking my answer when I can. So I'm going to check my solutions, make sure I have the right answer. I'm going to go back up to the system of equations that we started with up there. Negative 2x plus y equals negative 3, and x minus 4y equals negative 2. And I'm going to check to make sure that that actually solves the, see, I can look at it right here as well in the matrix, the augmented matrix. So I'm going to do negative 2 times 1 plus 1. So there's negative 2x plus 1y equals negative 3. Oops, what did I just do? That didn't work. It's because I plugged in the wrong value for x. X is 2. So don't do that. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 4 plus 1 is negative 3. So that one worked. Now I'm going to check the other one because it has to work in both equations. So I've got 1x, so that's 2, minus 4 times 1 equals negative 2. They both work. They are both true statements. And since they're both true statements, 2, 1 is the solution that I was looking for. All right, let's do example 2. We wrote our augmented matrix up earlier. So let's just repeat it. So top equation gets the top row. Bottom equation gets the bottom row. But I'm going to immediately switch row 1 and row 2 because I need to have the 1 in the upper left corner. So I'm going to switch the 2 rows, just like we did in the last one. We're going to switch row 1 and row 2. We'll just do a little row switch. So I have 1, 3, 1, 3, negative 2, positive 14. Now, we need to finish column 1. I need a 0 right here where this 3 is at. So remember, I only have 3 things I can do. I can switch rows. I can multiply a row by a non-zero number, or I can add a multiple of one row to another. So we're going to need to use that third option. So we're going to do negative 3 times row 1 added to row 2. We'll put that in as our new row 2. I'm going to pencil these numbers in again. So negative 3 times row 1 gets me negative 3, negative 9, negative 3. Let me add those up. Top row's not changing. And as I add those, I get 0, negative 11, positive 11. Okay, column 1 is finished. Now I move to column 2. I need a 1 right here where this negative 11 is at. Okay. So I'm going to do negative 1/11 times row 2 and put that in as my new row 2. Okay. Top row is not changing right now. Don't try to do too many steps at once or you get lost in the process. And your teacher will get lost in the process too and not be able to find out where you made your mistakes. So we now have that, and we're going to now use the 1 that's sitting right here to get a 0 where the 3 is at. So we're going to add a multiple of row 2 to row 1. What multiple? Well, we'll do negative 3 times row 2 added to row 1 because that will get us a 0 where we need it to be. Okay, so we're going to do negative 3 times 0, negative 3 times 1, negative 3 times negative 1. And we're going to add those up. So we have 1. Notice how the 0 that I'm adding to the 1 didn't change it. I still have my 1. 1, 0, 4. And then bottom row is 0, 1, negative 1. So we now have this augmented matrix reduced to where we can see the solutions. X equals 4. 1x plus 0y equals 4. And the bottom one, no x's, 1y equals negative 1. So our solution is 4, negative 1. And remember, a good strategy is to check your solution. So I'm going to really quick check my solution. I have 3 times x is 4. I'm going back up to the original system of equations. 3 times 4 minus 2 times negative 1. Is that 14? Yes, that's 12 plus 2, which is 14. Okay. Then for the second equation, and we're going back up here again, x, which is 4, plus 3 times y, which is negative 1, equals 1. And does that work? Yes, because that's 4 take away 3, or 4 plus negative 3. And we're done.